when electromagnetic spectrum it travels through the atmosphere, it interacts with the atmospheric constituents. Okay, so basically there are four types of interaction with the object, with the atmosphere, everything that through the medium that the electromagnetic spectrum passes. So if you will see, the major thing is when energy transmitted from the source, that may be an artificial source. So when energy transferred from the source, it passes through the atmosphere and scattering, then here it is transmission and reflection. These four interaction processes are done. Okay, so one by one we will see what are these interaction processes. So first of all, what is scattering? So when when energy, when the electromagnetic waves passes through the atmosphere, these waves interact with various constituents with various sizes, with particles of various sizes of the atmosphere. So when it falls on that particle, it gets scattered. Okay, it gets scattered. So if you can take an example that when scattering is nothing but a type of reflection, you understand that scattering is nothing but a type of reflection only, or you can say scattering is a diffusive reflection, not a specular. Diffusive reflection. Diffusive reflection means, scattering means in simple language reflection in every direction. Okay, when you you put a light on a uneven surface, that light propagates in every direction. From a single source, I am putting a torch. From here, light propagates in every direction. So that is only scattering. Scattering is nothing but a diffusive part of reflection. Okay, so this scattering depends on the size of the particle with which these waves interact. Okay, so these waves interact. So these waves having some, what is the size of the waves? That depends, that is the wavelength. Wavelength is the size of the waves. So that is the definition, the size of the waves. So now there are particles which are smaller than this wavelength, which are equal to that wavelength, and which are slightly higher than the wavelength, particle diameter. Okay, the particle diameter sometimes higher, sometimes lower, and sometimes equal to the wavelength of the electromagnetic spectrum propagating through that particle. So based on that, there are two types of scattering: non-selective scattering and selective scattering. Okay, so basically non-selective scattering happens when the particle size is greater than wavelength, okay, of the EMR. And selective scattering happens when particle size is equal or smaller than the wavelength. Okay. Okay, so this is the thing. Now if you will see what is non-selective scattering. Okay, so here you can see the example of Rayleigh scattering, Mie scattering. Okay, these are selective scatterings. Selectives. So selective scattering again divided into Rayleigh scattering and Mie scattering. Rayleigh scattering when the particle size is smaller than wavelength. Mie scattering is similar or equal equal to the wavelength. Okay, equal to the wavelength. So basically you can say there are three types of scattering: Rayleigh scattering, Mie scattering, non-selective scattering. In Rayleigh scattering, there is the particle size is smaller than the wavelength. In Mie scattering, the particle size is equal or similar to the wavelength. And in non-selective scattering, the particle size is greater than the wavelength. Okay. So in non-selective scattering, you what are the particles? These are the basically these are the water molecules. Okay, these are the water molecules present in the atmosphere. Okay, these are all what larger than the wavelength. The particle size is larger than the wavelength. It or this is cloud, fog. These are water molecules and or dust. Okay, these are the larger particles than wavelength. So they scatter particles, okay, much larger than the wavelengths involved. Okay, so this is non-selective scattering. All so what happened? What happens? These all particles scatter all EMR equally. All EMR equally. So all type of electromagnetic radiation that reaches this particle, they are scattered equally. So if they will scatter equally, the Vibgyor visibles, these will be scattered equally. If these will be scattered equally, then you will see which type of color. Anyone? Anyone? If all primary colors will be scattered equally, then which type of colors will you see? White, exactly. White color you will see, because red, green, blue, everything are scattered equally. So every wavelength is reaching your eye at equal intensity. So you will get white color. That's why the clouds, okay, the fogs, these are all white in color. They all appear white. These water molecules in the clouds and fogs, they appear white because of this non-selective scattering. Okay, so everyone understanding? Doubt, then ask me. Okay, so next, in selective scattering there are two types. One is Rayleigh scattering, one is Mie scattering. So Rayleigh scattering, what happens when Rayleigh scattering occurs? When particle size is smaller than wavelength, than the wavelength. Okay, particle size is smaller than the wavelength. So it is also called as molecular scattering. Why? Because the wavelength, the particle size smaller than this wavelength is all are these molecules, gas molecules like nitrogen oxides, oxygens, okay, ozones. These are all the particles which are the basic reason for Rayleigh scattering. Okay. So Rayleigh scattering is inversely proportional to the fourth power of the wavelength. This is just a relationship. Just remember this. Okay, the Rayleigh scattering is inversely proportional to the fourth power of the wavelength. Okay. So if you are seeing there, consider this is Rayleigh scattering RS is inversely proportional to the of it will be scattered less. Okay, this implies that shorter wavelength are scattered more than long, because most of the longer wavelength will be scattered less and shorter wavelengths will be scattered. So now in this Vibgyor, Which one is the shortest wavelength? Which one is of the shortest wavelength? Yesterday I told you. Which one? Violet. Okay, violet. But our primary color is RGB. Okay, primary colors are RGB. So this blue. Okay, this blue. So what happens as the atmosphere of Earth is full of these gas molecules, nitrogen, oxygen, carbon dioxide, argon, okay, full ozone, full of like maximum portion of the atmosphere of the uh, uh, your earth is full of these molecules, so the wavelength is scattered more, the shorter wavelength is scattered more, that's why it appears blue, that's why atmosphere of the earth appears blue, okay, due to Rayleigh scattering. Okay, so if you will see the sky of the moon, yeah, you will see what you will see if you will see the sky of moon. Anyone try? If you will see the sky of moon, what you will see? First of all, there is no sky in moon because there is no atmosphere in moon. If there is no atmosphere in moon, then there is no sky. Okay, so that's why the moon, when you stand on the moon, everything up only the moon's surface appears white, otherwise all the things appears dark only. Okay, if you will see the photos of moon, here you will not see. Okay, we'll go to Google Earth. In case of moon, there is no atmosphere. If there is no atmosphere, there is no scattering. If there is no scattering, there will be no colors. If all wavelengths are scattered, then it will appear white. If there is no scattering, then what will appear? It will appear nothing, only dark. Okay. Now the thing is, why in the evening and in the morning, in the early morning and the evening, why the sky appears this reddish color? That is the question. If blue color is scattered more by the particles, by the stars, then in the evening and in the morning, why the sky appears blue? Sorry, appears reddish. Why? Can anyone say? No, Rajesh, not due to terrestrial radiation. Terrestrial radiation are of longer wavelength and that are trapped by uh, clouds only. Okay. Yes, yes, exactly, exactly. Yeah, yeah, exactly. The thing is, in the morning and in the evening, what happens? The sun, this is the earth, the sun is here. Okay, so you are standing here. So the sun rays have to travel more. If it will have to travel more, only the longer wavelength will survive. The shorter wavelength will be scattered and it will be destroyed or destroyed before इतना स्कैटर हो जाएगा कि वो पहुंचने से पहले ही खत्म हो जाएगा. Okay, it will be ended before it reaches you. So only the longer wavelength which are less scattered, this will only reach you. So that's why you will only red, all this color will be totally scattered. Okay, this red color. So you are seeing red and evening blue. So this told everyone, yes. So this is helix. We go to yes cut. Yes cut meaning happens. Hello. Wait. Very shorting. So in Mie scattering, what happens? Uh, it uh, the particle size is similar to the size of the wavelength. Okay, so it is basically the aerosols. Okay, aerosols and the coarse suspended particles. Okay, so these scattering um, are basically important in lower altitude, not in the higher altitude. These are all important in lower altitude. So this Mie scattering, as these aerosols constituents, these aerosols constitute very less, and this scattering is not happens in a very considerable amount. Okay, that's why this Mie scattering is the wavelength size in this Mie scattering is used for remote sensing. Okay, because it will the energy, the electromagnetic spectrum that passes through the atmosphere will not much be scattered. If it will much scattered, then okay, so there should be minimum scattering environment or atmosphere. So that's why this Mie scattering wavelength range is used for remote sensing purpose. Okay, remember that. So Mie scattering occurs due to these aerosols, and aerosols are very less. Only this thing is important for Mie scattering. Okay, now one example. See, next we are moving to absorption. Okay, next we are moving to absorption. Absorption is nothing but you all have studied or listened the term albedo. Okay, albedo. It is the thing that some amount absorbed and remaining amount is reflected. So a flower, a white flower appears white, a red flower appears red. Why? Because it absorbs all the wavelength and uh, and transmits only or reflects only the red color. So that's why it appears red. In white color, it reflects all the colors back. So that's why it appears white. Okay, so that is the absorption. So you know, all of you know the highest absorption, is done by snow or fresh snow, you can say. Sorry, highest reflection is done by fresh snow. it almost reflects back 90% of energy incidented on it. Okay, and the deep water absorbs almost all the radiation. Deep water absorbs almost all the radiation. No reflection is done from these deep waters, or you can say deep oceans. Okay, this is the absorption. So the spectral regions of least absorption in the atmosphere. Okay, in the atmosphere, this is given here. So upper ultraviolet, visible and photographic, this is 95% transmission. Reflected infrared, these are the transmitted. Thermal infrared, these are the transmitted wavelength. And microwave, this I cannot see actually. Yes, greater than 5000. So for microwave, you can see the atmosphere is transparent. So that's why I have told you yesterday why microwave is used for this thing. Okay. So this is the thing, absorption. Next, so here you can see the electromagnetic radiation is incidented, something is reflected back, and something is absorbed and transmitted. Absorbed and transmitted. Something is absorbed. Here something is absorbed, and this is the transmitted one, and this is the reflected one. Will be absorbed within the element or within the object, and something will be transmitted and something will be reflected back. So if you will see, so here you can see the equation. Energy incidented is energy reflected, energy absorbed, and energy transmitted. Okay, energy incidented is equal to energy reflected, energy absorbed, and energy transmitted. Okay, this total thing is the incidented energy. Okay, so simple equation is there. So if you'll have to calculate the energy reflected, then energy incidented minus energy absorbed plus energy transmitted. Simple thing. So this is the reflection mechanism. Okay. So you all know reflection. What is reflection? What is incident angle? What is reflection angle? What is Snell's law? So I am not going to that. So in case of reflection, there are two types of reflection. I have already told you in case of scattering, that is specular reflection and diffusive reflection. Okay. So specular reflection, what is specular reflection? This is specular reflection. Perfectly came one wave and perfectly reflected back without any scattering in any direction. This is done by mirror-like surfaces, mirror-like plane surfaces. Okay, plane shiny surfaces. This is done by plane shiny surfaces. Specular reflection. Perfectly one wave came and perfectly one wave went out. That is specular. But in case of diffusive reflection, what happens? Okay. See, here it is diffusive reflection. It is also diffusive reflection. It is also diffusive reflection. This is called Lambertian reflection. Lambertian. Lambertian reflection is that type of reflection in which diffusive reflection is equal in every direction. See, here the vectors are equal in every direction. Okay, here the vectors are more, here it is less. So, specular reflection is direction, one wave comes and one wave goes out, and diffusive reflection is that you call scattering. One wave comes and many waves are reflected. That is diffusive reflection. And Lambertian reflection is type of diffusive reflection in which all the reflected waves equal in length. Okay, that is Lambertian reflection. Everyone understood what is reflection, specular reflection, and diffusive reflection? Written here. So here you can see there is a side looking airborne radar. In particular, number of variation occurs because of the sensor. So there are different type of sensors. Okay, one is side looking, one is straight looking. Okay, side looking means here there is a platform and it is the side looking. So this is the object of observation and this is the platform. So it is side looking. Okay, this is straight looking. This is looking like radar. These are not, these are advanced remote sensors. Radar detecting. Okay, these all work on reflection mechanism. An source uh, makes out these radio waves. It hits one object and it reflects back. Sensed by a sensor and takes a small image. Disaster management for disaster management. Okay, so now we are going to satellites and orbits. So everyone understood till now what I have studied. We have all understood the basics of remote sensing, how remote sensing works. Okay, how remote sensing works, what are the processes, okay, how the satellite is sent. It is not of our cup of tea. Okay, so that is engineer, aeronautical engineers cup of tea. So now the thing is, this PSLV, this SSLV, GSLV, they all remote sense platform to the satellite orbit. So there are orbits. So there are orbits. There are two type of orbits. Mainly there are two type of orbits. One is geostationary orbit or geosynchronous orbit. Another is polar orbit. Major orbit types: geostationary or geosynchronous one, or you can see here, if I draw, revolves horizontally, one revolves the orbits type of orbit. One revolves with the synchronization of the equator. These are the main two type of orbits. Now the thing is, there are various uses of remote sensing. Okay, there are various uses of satellite. So from that, for example, communication, for TV, video communication, mobile communication, internet. Okay, this is communication. This is one purpose. This is one purpose. Second is your military purpose. Okay, military purpose or defense purpose. For what the second purpose. The third purpose is disaster management. Okay, disaster management. In this disaster management, you can, or I am including all the things like agriculture, okay, atmosphere, everything. Okay, or we can divide. Third is disaster management, like studying the cyclone, earthquake, landslide, your flood, and your glacier lake outburst flood. Okay, then cloud outburst. These all things can be studied. This is third. Then fourth, agriculture. Fourth is agriculture. For agriculture, what you can study? The advancement and retreatment of monsoon. What is the cloud? Where it will rain? Where it will not rain? Okay, this is for agriculture, and also you can include the climatic studies, climate and weather. Okay. Next, this is fourth or fifth. This is now it is sixth. Now sixth number is you can also use for blue economy. Blue economy means for ocean things, fish, where the fishing, where the nutrient rich water is there, so there will be more fishes. Okay, that also you can include in agriculture, pisciculture, that will also include in agriculture. So sixth you can say the planetary. The planet, how what was the evolution of Mars? Okay, now Aditya L1 has went. Okay, what was the evolution of the solar system? So there are various study things, various ways of studying things. There are various uses of these satellites. Okay, so can anyone tell why we are studying sun? What is the benefit? What is the benefit of humankind for studying this? Why you have spent so much money to send Aditya L1? Okay, what is the benefit? In spite of that, that money should be spent in education or feeding the poor. Okay, why they have sent this like give that even to the humankind? So now the thing is, satellites, I have told you many benefits of satellites. So, so based on their use, they are placed in certain orbits. Okay, based on their use. So, basically, the remote sensing satellites are polar in nature, polar orbits, and the communication and your military grade satellites. These are all geosynchronous in nature. Okay, so first we will go to geostationary orbit. So before we are going to the type of orbit, we will go to some terminologies. Okay, some terminologies. So first is orbital period. Orbital period is the time taken by the satellites to completely revolve around the Earth. Okay, or complete its orbit. That is orbital period. Second is altitude. Altitude is how much height it maintains from Earth surface. That is altitude. Apogee and perigee. Perigee is the see. This is an elliptical orbit. So perigee is the shortest point, and apogee is the longest point. So according to Kepler's law, you know that this planet is placed one of the foci of the ellipse, and these satellites roam around it. Okay. So this is Kepler's law, apogee and perigee. This is perigee, this is apogee. Okay. Inclination. So this orbit is how much inclined from this equator. Okay, from this 0 degree, how much inclined. So this orbit can be, this is the Earth. This orbit can be like this, or like this, or like this, or like this. So who will tell what the inclination of polar satellites? What will be the inclination of polar satellites? Nearly, not precisely, nearly. Tell approximately what will be the inclination of polar satellites. Tell me. This equator is 0. Everything that passes this equator, yes, correct. So nearly 90 degree. Okay, nearly 90 degree. It is near 99, 98. Okay, these are the inclination of polar satellites, but it's approximately 90 degree it should be. Okay, pole to pole. So this is inclination. Then Nadir. Nadir point, see Nadir point. Nadir point is the shortest point from the satellite. If this is the satellite, this is the shortest point, shortest distance from the satellite to the Earth's surface. This is Nadir. And exactly opposite will be the longest, that is zenith. You are getting it? Nadir is the shortest point from the satellite, or shortest distance from the point to which there is the shortest distance from the satellite to the Earth. That is Nadir. And exactly opposite will be the longest, that is zenith. Okay. Any point just opposite to Nadir above the satellite is called as zenith. Okay. So then ground track is, this is the ground track. Okay, this is the ground track. Like ground track is, this satellite is roaming in this track. This is ground track. So this in case of your satellites, the whole Earth it covers by ground track. Swath is the angle. See, what is swath? Swath is, if this is the satellite, this is the camera. This camera can capture this much of area. Like your eyes can capture 120 degree. Okay, 120 degree angle. But there is a certain distance. This distance is swath. Okay, like this camera swath is this much distance it can capture. Okay, it may be 12 kilometer, it may be 30 kilometer. Okay, this is the swath. Everyone getting it? What is swath? Perigee is a point. Perigee is a point on the orbit. Perigee is a point on the orbit. Okay, this is Earth. This is the satellite. Perigee is the shortest distance from the Earth at which satellite is placed. This is Nadir. This is Nadir point. Okay, when this satellite will be here, this will be the Nadir point, not this one. When the satellite is here, this will be the Nadir point. Nadir point is you can say variable, but perigee is always constant. Okay, so this is swath. Next, side lap and overlap. What happens? See what happens. This is consider, this is the Earth. This is Earth, and this is the satellite. It is scanning. So this will take photo of this one, this area. Okay, now this will take photo of the up area, then this area, then this area, then this area. Then it will rotate backward, ऐसे ऐसे करके ये निकालेगा फोटो पीछे से, फिर आएगा इधर से. ओके, फिर इधर से ऐसे फोटो निकालेगा. So you are getting it. step by step, one photo, second, third, fourth, sixth. Remote sensing is nothing but photography, taking photo with your camera, nothing, that's all on. ओके 1 2 3 फोटोज ले रहा है ये, ओके ऐसे ऐसे कैप्चर कर करके फोटो ले रहा है. तो now I'll show you how it takes photos. Okay, after you understand this, I'll show you how this side lap and overlap occurs. So you can see this. So if the track, this is the ground track. Yeah. So this is the ground track. So if it takes one photo, then it will not take exactly at the boundary. It will take just before the boundary. This is the overlap. This thing is the overlap. Okay. This thing is the overlap. This should be there. Otherwise, there will be missing part, because who knows, this thing is perfectly boundary photo is taken. Okay. So there should be some overlap. Next, when the second track is going on, this should not be like this. There should be some side lap. Okay, side lap. This is the side lap. एक फोटो आगे जो फोटो ले रहा है थोड़ा सा ऐसे ऊपर से ले रहा है, ऐसे नहीं, ये साइड से थोड़ा इसके ऊपर चढ़ के फोटो ले रहा है. ठीक है, ऐसे पूरा पैरेलली लेके नहीं ले रहा है, बाउंड्री टू बाउंड्री, ऐसे थोड़ा चढ़ के ले रहा है. दिस इज साइड लैप, दिस इज ओवरलैप. ओके, so I'm showing what is side lap and overlap, how the ground track is going on. I'll show you. Okay. So you just go to Bhukosh. Sorry. Okay, let's search for open data. I'm giving a date 20 to 20 December, 1 month. Okay, we'll first go to priced list for data. Will go. Okay, it will be better. Satellite. Cartosat. Open. So satellite. Resource set where will go list 4. Okay. So sensor type list 4. Okay. Data and submit. I have selected now. List 4 I have selected though. Satellite sensor. Open data direct download. Open data on order. List 4. Huh? List for have two resolution 23 and 70. This is area of interest. Area of interest we have to give. Okay, let's give the area of interest. Polygon. Okay, so Google Maps. कुछ भी ले लेते हैं, 12 वाटिका ले लेते हैं इसका। लॉन्गिट्यूड ले लेते हैं, तो 20, 28, 55, 2, 20.55 consider it is 85, 51, 85.51, 100 kilometer radius. Okay, so but no more results applicable. Okay, so we'll change the date. Submit. अरे wait, this is the area. Actually, this Hunadi portal is good. Hunadi portal got updated just 15 to 20 days ago. Polygon location, decimal. See, so these are the data. Okay, because we are or AR. Okay, this is one. This one is So here you can see this is one, okay, this one, and I have taken this is this is the photo, okay, this is one data, this is one data, and this upper one is also another, okay, this upper one is also another. So this is in the same track, but see this is this area and this area, इसका एरिया देखो, इसका एरिया देखो, ये देखो बीच वाला ये है ओवरलैप, देख रहे हो इसका, यहां से यहां तक इसका है ओवरलैप, दिस पोर्शन, ये देखो इसका और इसका, इसका जो बाउंड्री कर दिया है सियान कलर में, इसका बाउंड्री आ गया है, और इसका हाईलाइटेड येलो, देख रहे हो इसका ओवरलैप, देख रहे हो सब लोग। वैसे ही ये एक ट्रैक है, ये एक ट्रैक है, देखो इन लोगों का साइड लैप, इन लोगों का साइड लैप देखो कितना हो रहा है, ये वाला पार्ट जो देख रहे हो ना रेक्टेंगल पार्ट, ये पूरा इन लोगों का साइड लैप है, देख रहे हो, एवरीवन इज गेटिंग इट, व्हाट इज ओवरलैप एंड साइड लैप? These are actually remotely sensed data we can download and we can view, okay. So these are the side lap and overlap. So if you want to see the ground track, you can also go to Bhunidhi, so Vista, Bhunidhi Vista. So here you can see now which of the satellites are where roaming around, okay, at which place they are roaming around. It will come. It is not there. Wait. Bhunidhi. Yes, up graph. Yes, here it is. Okay, it is not available. It is not available now. Okay, it will be available. So here you can see actually which sides are moving around which path now at present. Okay, you can view here. So this is, you can see this is one path of one satellite. Okay, it has all gone up and down. This is ascending path and this is now descending path. Okay, this is descending path from Russia towards Australia. This is ascending path. Okay, it is roaming around the earth. Here it is shown as a straight line, but it has a curved path. Okay, it is not opening now. Maintenance downtime. Okay, so everyone understood what I was showing? What is the side lap, what is the overlap? Okay, everyone understood how the satellite ground track works. Then this graph thing is not coming, otherwise I will show the ground track. This is side lap and overlap, I have told you. Now, so geosynchronous orbit, basically what happens, we have to, if geosynchronous orbit means what? The orbital period is equal to the revolution period of Earth. Means 24-day is the rotation period of Earth. Rotation period of Earth So it should be 24 hours, sorry, 24 hours period of Earth. It should be equal to the revolution period of the satellite. Simple. ओके, और सैटेलाइट उसी स्पीड में उसको चक्कर लगाना चाहिए, so that it can focus on a constant point. Okay, at a constant point, because this point will move at a 24-hour speed. Okay, this point also, this satellite will also move with that. So to maintain speed, the height should be certainly a particular at a particular altitude, because of this gravity, na? Because this gravity maintains, this gravity rotates this satellite around its path. So there should be certain height which will maintain this speed, with the Earth rotation period. So that height is 36,000 to 38,000. Okay. So majorly these are placed at 36,800 or something. Let me see. So 36,000 to 38,000. Majorly these are placed at 37,400, 37,500, this type of height. Okay, 37,500, 37,400, this type of height. So this height should be maintained from the altitude, so that the gravitational force will rotate it, or the satellite will revolve at a constant speed of the rotation period of the Earth, that is 24 hours. Okay, so that is geosynchronous orbit. Geosynchronous orbit means this thing. Okay, so this geosynchronous orbit, they told, like in books, it is written that geosynchronous and geostationary orbit is different. Geostationary orbit is that orbit which is exactly parallel to the equator, and geosynchronous is slightly inclined, but both are same. Simply geosynchronous, geostationary, these satellites having revolution period equal to the rotation period of the Earth, because you have to, this satellite have to continuously cover a single place only. Okay, you can move the satellite for capturing the different place, but you have to continuously see that place only. So why this satellite will be used? Anyone? What will be the purpose of this satellite? Climate monitoring. Do you think for climate monitoring this thing is required? Communication and military purpose, exactly. For climate monitoring, we do not need minute data. So for climate and other things, we do remote sensing. We do polar. Okay, so that it will rotate after 1 hour, after 2 hour, or after 3 hour, it will give us data. Okay, so for communication and military purpose, these satellites are used, because it will cover a fixed, it will serve a fixed area. The GPS, global position system, this consists of 24 satellites. 24 satellites, all are geostationary. Okay, so see, you can track satellites, but this is not the purpose of use. Okay, you can track satellites by using all you can track cyclone by seeing all type of satellites. Okay, but you do not have to continuously focus on that place only. You are getting it? So you will, if you will if you will see continuously the one place, na, the variation you cannot monitor. You have to see after 2 hour, 3 hour, 4 hour, then only the difference you can get. So for communication and military purpose, these satellites are used. InSat, Meteorsat is also geosynchronous sat. This is for long term, long term climate. Okay, not for cyclone, long term climate, or you can say cloud movement. Okay, so these are very high altitude footprints of yes. If you are going to high altitude, then the swath will be very higher. Almost it you will cover the earth. Most. Na? If you will go to lower altitude, the swath will be lower. This same satellite, if went here, consider this is 45 degree. I am turning it here 45 degree. Then it will be higher. Then again higher. So this, because of this high altitude, this whole 45% of Earth is covered by one geostationary satellite. Okay, but these polar satellites are only 700 to 800 km height. These are 36,000 to 38,000 height. So you can see here almost 45%, 50% Earth is covered by one geostationary satellite. Okay, everyone getting it? So this is polar or near polar orbits. They travel pole to pole. Okay, pole to pole they travel. So you can see the path here. You can see the path. These are the photos taken. Okay, these are the ground tracks. They rotate like this. Okay, pole to pole. Okay, they are 700 to 800 km height. Their orbital period is generally 90 to 103 minutes. Okay, in 190 minutes to 103, they complete one orbit around the Earth, means pole to pole. Ascending, descending, ascending, descending. Okay, this complete takes 90 to 103 minutes. Depending on height, if you will go to more height, it will take more time. If you will keep in less height, it will take less time. Okay. The satellites of the polar orbit are one revolution of the Earth in a single day, many revolution, more than one revolution around the Earth in a single day. So that's why the repeativity of same place photo comes in 2 days, 3 days, 4 days, this day. आज लिया है से सेम सैटेलाइट से मैं 3-4 दिन के बाद ही इस जगह का फोटो मिल जाएगा मुझे, क्योंकि वो उतने दिन में पूरा अर्थ को सर्कल करके पूरा अर्थ का फोटो लेके चला आएगा, क्योंकि ये तो यहाँ पर रोटेट कर ही रहा है, उसके नीचे अर्थ भी रोटेट कर रहा है, समझ रहे हो कि नहीं? तो उसका फोटो वो कंटिन्यूअसली निकालते जा रहा है, कंटिन्यूअसली निकालते जा रहा है. ठीक, तो दिस इज पोलर टू नियर पोलर ऑर्बिट्स. So completed when the satellite retraces its path, that is when the nadir point of the satellite passes over the same point on the Earth's surface for a second orbit, polar satellite. पोलर सैटेलाइट का ऑर्बिटल पीरियड क्या है? ऑर्बिटल साइकिल, अगर यहाँ पर इस पोजीशन में अर्थ में ये क्रॉस किया है, वही पोजीशन में कितने टाइम में आके क्रॉस करेगा, दैट इज ऑर्बिटल साइकिल. ओके, ऑल्सो दिस इज नोन एज रिपीट साइकिल. But revisit period, this is different So this is called as orbital cycle and repeat cycle. Revisit period, what is the revisit period? Revisit period is like when you roam around the same place. Okay. So what is the difference between or repeat cycle and revisit period? In repeat cycle, you have to go to same place, same point. Like you can say, I am showing you, this is Earth. This is, consider this, this has X, Y, latitude and longitude. This satellite should be over that. When this will be second time over there, this will be the orbital cycle. But revisit, this satellite may be here, but the photo consists of this longitude, latitude, these coordinates. This is revisit period. Getting it? So basically revisit period is less than the repeat cycle. Okay. So revisit period and repeat cycle. Revisit period is same place you can view, but repeat cycle should be same latitude, longitude. Over there the satellite should be there. Okay. Sun-synchronous orbit is also a polar orbit. Okay, but the difference in polar orbit and sun-synchronous orbit is what happens. आज अगर 9 बजे यहां पर क्रॉस किया है 9 AM, then tomorrow also 9 AM it should cross at the same local time each day. In a sun-synchronous orbit, the satellite passes over the same part of the Earth at roughly the same local time each day. Roughly. Okay. So आज अगर 9 बजे यहां पर क्रॉस किया है, कल भी 9 बजे ही क्रॉस करना चाहिए. That is sun-synchronous orbit. Same local time. It may be night, it may be day, but the time should be same. ओके रात को 9 बजे मतलब कल भी रात को 9 बजे, आज सुबह 10 बजे मतलब कल भी सुबह 10 बजे. That is sun-synchronous. Sun-synchronous is a special type of polar orbit only, nothing else. Okay, these are the tracks of polar orbits. You can see these are the tracks. Okay, these are the polar orbit. Okay, so that's all for today. My battery is down, charger is not working. I have to show the charger. Everyone.